My wife really loves flowers, especially tulips. And when she moved to the Netherlands about 2.5 years ago, coming from Asia, she soon found out that the food in the Netherlands isn't all that great. Neither is the weather, because like today, it rains most of the time. But we do have amazing flowers, especially tulips. And when she was just in the Netherlands 2 years ago, we went to a place called the Keukenhof. Now, for those who've never been there or never heard of it, it's a place with millions of tulips, literally, and some other flowers. And she really loved it. We walked around for hours, we made pictures. It's an amazing place. Of course, we wanted to go back last year, but yeah, because of Corona, we couldn't go. And this year was a very similar situation. It's impossible to go there now. So rather than go to the Keukenhof, we actually decided to buy a new home and create our own little Keukenhof at home. As you can see, we're still not there yet. We're making the first steps. But anyways, maybe next year. And of course, we don't just grow tulips in our garden. We actually also buy a lot of flowers. And, as my wife's birthday is the day after Valentine's Day, I'm always confronted with the fact that, 2 days in a row when the prices are the highest, I have to buy flowers. So it really got me thinking about the process of, how do they determine the prices and how do they, on these peak days, get all these flowers from the producers to the consumers. So today's presentation is not going to be about flowers, it's actually going to be about data, because a lot of the challenges we have to solve around data are very similar to what we have to do around flowers. But I'll get to that in a bit. Good afternoon, everybody. My name is Ferd Scheepers. I'm the Chief Information Architect at ING and the Chief Architect for ING Tech Group Services. And today I'm going to talk about why a data lake really needs open metadata. So when my wife really loves flowers, I really love data. I really love technology around data. And I've been in this job for about 7-8 years. And when I started, we created this architecture, which we call the ING Data Lake Architecture. It's quite a complex picture. I'm not going to elaborate too much. Inside ING, we often call it the picture with the many boxes. But it really describes a governed data lake where a central catalog is instrumental in making sure we understand all the data in the data lake and we govern it from the beginning to the end. If you want to see what the essence is of the architecture, this picture illustrates it very well. We bring in all the data from all systems of records into the ING data lake. Everything raw, and then in the data lake we start transforming it into a common language. We actually put it in a number of little boxes where every consumer can start looking at that data, and since they understand the common language, they can just put the data together that they need and use that data for their purpose. It's in essence what we're doing today. I'm a native Dutch speaker, I'm speaking English, so that everybody who also has a different native language, whether you're German, whether you're French, whether you're Japanese, you can understand what I'm saying because we have a language in common. This architecture works quite well. We don't only use it for analytical purposes, we also use this for delivering data to our regulators. All the major programs at ING actually use the ING Data Lake architecture. And it's giving us a lot of value, but we also see that it's not perfect. Not per se that the architecture is not perfect, but it's really about the amount of work that it takes to bring your data under governance, which we thought originally would be kind of like easier over time. But we find out that each time we bring new data in the data lake and under governance, we still need the same subject matter experts. We still need to have a lot of manual work involved in labeling the data, describing it, making sure we can map it to the ING Esperanto. So in that sense, there's too much work involved in actually getting your data in, and that is starting to slow us down. The second problem that we see is that as we are a very international organization, we have data lakes in multiple locations. We have them in Australia, we have them in Europe, we have them in different geographies. And there's really good reasons for that. Also because some geographies like Turkey, they actually make sure that the data has to remain there. You can't just take that data and move it to another place. But in essence, there is a lot of movement of data between those different data lakes. And those are all, crafted by hand. This is not automated. And as we have multiple of those data lakes and we see kind of like more and more data need to be exchanged, also because we're an international bank, we fall under the ECB regulation. So a lot of data we need to report on across the globe. There's a lot of movement that we have to create, either create ETL jobs to pull in the data to a different data lake, etc. It's a lot of work, a lot of things that we have to do by hand. And as we move to the cloud, to the public cloud, that the complexity just increases. On-prem, we can slowly reduce the number of physical data lakes, but we move more and more data to cloud, and we need to govern that data in the same way. So we see more and more need to copy data around, create jobs to move data to cloud, but also to make sure that those policy enforcement points that we have, to make sure that we understand which data can move to cloud, which data can move from one country to another, that we make sure we understand that and we govern that very well. So it becomes an architecture that involves a lot of things we have to build ourselves to make sure the data moves around and the data doesn't move around when it shouldn't move around. This is actually a logistical challenge around data, and it's in that sense not very dissimilar to what we see in other industries. Logistics is all over the place, and I get back to my flowers. This is a picture of the flower auction in Aalsmeer, which is the biggest one in the world. And a lot of the stuff that happens there is really about making sure that the product, in this case flowers, goes from the producer, the grower, to the consumer, well, you and me. And it looks like still a very manual thing. There's people driving about in cars, but if you look behind the scenes, it's all driven by metadata. There is labels to these cards. It really shows about, the flower comes from here, it's this type of flower, this is the quality of the flower. All these things are labeled, there's metadata around it, and when you as a consumer want to kind of like get the product, get the flower, you can look at that metadata and see what you're buying, what you're getting, what the quality is. And that whole process of kind of like you bring your flowers to the auction and the consumer gets it, it all goes via these labels, it goes highly automated. As a producer, you drop off your flowers and at some point in time you get your money. You don't need to be involved at all. And as a consumer, I'm also not asking, can I get the flowers from there or there? I don't need to know where the flowers come from. I just get the flowers I want because I understand what I'm buying. This is in essence, for me, what the data mesh is and what the data mesh needs to be. So it is this little set of cards that move data around and that bring it to the right location, driven by what Gartner labels as active metadata, the metadata that really drives what we do with the data. It's about moving data, it's about making sure we have the right governance on top of data. It's about making sure that when we want to consume the data in a location, whether that's a different physical location, different country or different cloud, we don't have to know where that data comes from. It's handled by the data mesh. It brings the data to the right place. It's also about, business terms being kind of like the way we identify the data. It's not about bits and bytes. It's about the semantic definition of data. We really have to understand what the data is before you can do something around policy enforcement. It's not about this table. It's about this table being an identifier of a person, right? There's personal data in there and that drives the policy. So data meshes for us are a very essential part of our journey towards the future of data management. And we believe in it, and actually we are working together with IBM on what we call a showcase around what IBM calls the mesh for data. We're actually building it together with IBM. We're doing engineering on this to show that this whole idea works. And the first showcase that we're doing is actually around policy enforcement. We simulate the situation where we have data in Turkey, and we have a consumer of that data in the Netherlands, and if that consumer wants the data, we find where the data is. We look at the policies. Can you use this Turkish data for the purpose that you want to use it? If so, the data is brought over. You don't even know that the data is being copied. If not, well, maybe you can redact the data or you don't get data at all. We love the data mesh. We believe in it. There's really good presentations about the data mesh today. I'm not going to go deeper than this, but there is something missing. And that something is really about If you use the data mesh and you actually get the data, you don't get the metadata. And it's a nice illustration when you buy flowers. The person who buys the flowers, the shop, they get the flowers, and with the flowers they get the metadata about the flower. There's a label there that says, this is the flower, this is where it comes from, this is the quality, the whole shebang. Because it's a physical product, you get the metadata with the physical product. And what we see with the data mesh, the governance is in the data mesh. But for example, let's say we have a data mesh from a certain vendor, and we connect that into Azure, and we will use Power BI to actually look at that data. Now, Power BI can easily access that data. It probably has a SQL endpoint or a set of APIs. But Power BI will look at Purview for its metadata. Well, guess what? Purview is unaware of the metadata that comes with the data mesh. Unless we have a data mesh from Microsoft, then probably it works. But then I would have the same situation in Google when I want to look at that data with Looker. So there is a need for metadata exchange, and that is something we, as ING, have seen many years ago already, and we're trying to address. So without that metadata, there's a number of problems that we have. Well, first of all of a sudden we don't know anymore what data we're looking at. Without that set of semantic definitions, without those business terms, we're looking again at bits and bytes. Am I looking at a date of birth? Am I looking at a date of opening an account? I need to know what that data is that I'm looking at. And that was one of the reasons we actually spent so much work on cataloging that data and describing it, etc. And all of a sudden, it stops at the data mesh. The products that sit next to it in the cloud, they don't have that data anymore, that metadata anymore. Second, a big issue is that, especially for banks in Europe, or actually any company in Europe, we no longer know beyond the mesh who's looking at the data. Of course, we have access policies on access to the data itself, but once that data goes into a set of products that are outside of the data mesh, we don't know it anymore. There can be transformations on top, and all of a sudden, the data has a new life, it has a new set of data sets, and we don't know who's looking at the data anymore. And that's a huge problem for us. And related to that, to the regulators, we need to prove the lineage of data. Where does the data come from? Where does it go to? What are the different steps it takes along the way? For banks, a very heavily regulated industry, lineage is essential, and we really need to show end-to-end the data, where it goes to, what we do with it. And we do have kind of like islands of lineage when we use the different technology sets, but it really takes a detective to stitch that all together and show that end-to-end lineage. And of course, my ideal state is that, when a regulator comes to ING, I just tell them, hey, listen, here's the lineage, starts at my system of record, goes to the report that we sent to you, and everything is in one place. So that's the challenge that we have, and that's what we really try to solve. And actually, there's good examples of metadata and data being exchanged together. And one that I really like is the example of the JPEG format. So when you look at a JPEG picture, any camera, you make a picture, it actually captures a lot of metadata around that picture. And when you transfer that picture over to any other device, whether it's another phone or a camera or a MacBook or a Windows machine, you get the data, the picture, and you get the metadata. And any place you look at that data and that metadata, it's understood, it goes together. And you have the same thing with MP3s from the past. You had the data, the music, and all the information about the artist and the quality of that track. It was all in the data. So data and metadata were working together and being transported together. And with our data infrastructure, it doesn't work that way, because the data and the metadata, they're in separate places. So what we really need is next to this data mesh, which for me is kind of like a highway for data, we also need to have a highway for metadata. And that is what we, together with a number of vendors, have started to build a number of years ago. An open metadata standard and an implementation of that standard that we call Algoria. So it's really building that highway across those different metadata repositories so that they can exchange metadata, and actually tools that need metadata can go to this federated layer on top and get their metadata from the different repositories without having to know where they get the metadata from. So very much what the data mesh does for data. So what is Algoria? It's in essence two layers of APIs and events that make it possible for different metadata repositories to talk to each other. That is what we call the Open Metadata Repository Services layer. A set of APIs where different metadata repositories can standardize the format of metadata and exchange that data so that they are aware of each other's metadata and they can kind of like share that metadata for other consumers. And on top of that, a set of open metadata access services that make it possible for different tools to actually get their metadata across that federated landscape, not having to know where the different metadata sits. And they can actually ask the whole federated landscape a set of peer catalogs on what is there, what do you have, what's the lineage. All that information can go across those different metadata repositories. So what can we do to use Algoria in the different environments? So there is, for us, 3 different use cases that we see. So the first one is the metadata highway. So really what I talked about before, you have this exchange of metadata across different repositories. And it's possible for example, the place where you've governed your data, where you've mapped all those business terms to the data that you have, to exchange that information with another repository. So it doesn't only get the data, it also gets the metadata associated with it. So when you look, for example, in Purview at the data that you got from ING on-prem, you don't only see the data, you also see the associated mapping, and you know what data you're looking at. The second one is a set of capabilities around building your own UIs and tailored services on top. So for example, we want to see lineage across all those different repositories that we have. So we've built, as part of Algoria, an open lineage service, which makes it possible to actually bring all those different sets of lineage information together and build a UI on top of it, where we can show the end-to-end lineage across those different repositories. So we can really show our regulators, data comes from here, it goes to here, all the steps in between, independent of technology, I can show you. The third use case is we can use Algoria itself as a metadata repository, because we see that there is a lot of tools in the organization that don't have a true metadata repository. For example, we're building our own middleware at ING. It doesn't truly have a metadata repository. Well, guess what? We're going to use Algoria for that. So we put all that middleware, metadata in there, and we have a good place for it. And of course, it directly is integrated in this federated landscape. So we have all the metadata together, and we can share it, we can use it. So it gives us this layer that we truly need. So where are we? So this is live software. This is not an idea, this is not a concept, this is live. We've already implemented the first version of Algoria at ING. So we built this as open source. This is part of the Linux Foundation AI and Data. And at ING we've done the first implementation, which we call the Open Metadata Platform. And the first use cases that we have are really about finding metadata and showing the end-to-end lineage. This is now in production. This is working. We have ING's data lakes connected to it. We're now connecting more and more of our own functionality. And we're already doing some proof of concepts with different vendors like Microsoft, like Google, like Oracle, to also connect their metadata repositories. And this is really starting to give us value. We see that it works. We see that this exchange is possible. And those vendors also start to be more and more interested, and they're working together with us to make this a reality. So the next major delivery for us is actually around expanding this level of lineage, where we now have mainly focused on the vertical lineage, understanding the business term mapping to the database, to the tables, to the columns, etc. The next version is really to extend that horizontal lineage. So we can go a level deeper. We really can go the column-based lineage all the way. It's a lot of work. It's working code. We already have it. We're now struggling a little bit with some of the performance issues, but it will be solved within hopefully weeks. And then we'll be able to show really what we truly want to do, this end-to-end lineage of everything that we have at the bank, which is a very important use case for us. So, like I said before, we're not standing at the sidelines in this. So we didn't go to a vendor and say, hey, listen, we need something like an open exchange of metadata, make it so. We actually started to push this to the vendors, and we said, well, we see the need for this and we actually want to build it. So about, what is it now, 4 years ago, we started this initiative together with then IBM and Hortonworks, and we started to build this. We have, at the moment, I think about 10 people working on this full time. They built this in open source. Together with IBM, together with others, there's now, I think, 30, 40 people working on this worldwide. And over the last years, we've been joined by SAS. We now have working code with Microsoft, with Google, Cloudera, being the new company that owns Apache Atlas, where we started to work with Hortonworks. Together with all of them, we're building this. So ING puts a lot of engineering in this. This is one of the reasons we're also talking here. We really believe in getting involved in these kinds of things, building these things in open source and not keeping it to us, because we want to build an open standard, and we believe that if it's not there and we need it, we should just contribute. So there is an open standard. It's called the Open Metadata Standard. It's part of the Linux Foundation AI and Data. We have an implementation of it, Algoria. We're now at version 2.8, something like that. Have a look at it. It's all open source. It's all available to everybody. There's an implementation at ING. Of course, there's no link to that. I can't show you exactly what we have at ING, but if you're interested to know what we're doing with it, please reach out to me, or some of my team is also on the chat. So if you have questions or you want to talk about it, we can always do that. We really believe this is necessary. Yeah. So next Valentine's Day, if you buy beautiful roses for your loved one, think about the whole complex journey of how flowers, arrive at your home driven by metadata. But during your normal working day, please join us in making open metadata a success, because this is truly necessary. The data mesh is wonderful, but without this metadata integration next to it, it will not be enough. And like I said, please get involved. There's many ways. There is a website, we have mailing lists, there is a channel on Slack that talks about Algoria. And of course, if you want to contribute or you want to adopt Algoria, because it's open, you can use it. Reach out to us, please get involved. And if you want to talk a little bit about what we're doing at ING, reach out to me, reach out to my team. We'd love to hear from you. So thank you.
Hey, Ferd.
Hi there.
Thank you for an awesome presentation. Love the tulips. It definitely grabbed my attention. Thank you all for also attending today. As Ferd mentioned, we're going to open this time up for Q&A. I see we've got a couple questions in the chat already, but feel free to continue dropping those in. To kick things off with the first question here, Ferd, do you see an organization needs to have centralized governance in a decentralized data mesh architecture, such as centralized metadata through Algoria?
So definitely, governance is by default a centralized something. We need to have, especially in a big international organization like ING, we need to have one place where we govern our data. And independent of where that data resides, whether that's in a cloud, whether it's in a different country, it's company data of ING, and we need to have that governance done centrally. But we actually need to have the execution of many of those policies done decentrally. So what we think is that having a central place where we govern the data, where we describe the data, where we make it possible for everybody to also find all the data of ING is crucial. Many of the policies then need to be implemented decentrally. Doesn't mean that all the data needs to be central, definitely not. We really believe that the data needs to reside in the places where it originates, and you only bring it together when there is a need for that. But the governance on that data, we really think should be central. And the implementation of that governance need to be decentral. The idea that we had in the past, maybe bring all the data physically together in one place, bring all the metadata together as well. I think that's a concept of the past. It will be a distributed setup, but we really need to have a central governance on top where everybody can find the data, where everybody can know what kind of data assets we have in the bank, and where it's very clear that, from a regulatory perspective, we need to implement those governance policies.
Very good. And how does the data lake change with the data mesh? Does it mean we do not need the data lake anymore?
I've always seen the data lake as more of a logical architecture. It really describes, I have my data in my systems of record. I bring them raw into my central governed data lake. And the data lake doesn't have to be a physical thing. It's really about, all that data is now available for consumers. Now, all the data that I want to share with others, I need to describe. So I have a layer in the middle that really maps that raw data in the system of record format into a set of standardized business terms that everybody can now understand. So the concept doesn't change, the implementation does. Where in the past, maybe we would say, copy all the data into the data lake, then we move all that data into a central information warehouse, as we call it, and that is really done by mapping it to what we call the ING Esperanto. In a data mesh concept, we probably not pull in all the data. We pull in the data the moment that the data mesh actually decides that rather than the data being available on consumption, we need to pull in that data a little bit earlier, because the non-functionals determine that we need to have the data in there because, hey, the access will require a copy to a different location or maybe to a database that gives that high performance access. Conceptually, it doesn't change. Implementation-wise, it will change. So for me, it's kind of like Data Lake 2.0 with a new set of technologies underneath, but still with that concept of very highly governed description of data, access to data. Implementation-wise, will make it much more decentral. Data will only move when it needs to move. So in that sense, logically, it will be the same. Physically, it will definitely change a lot.
And do you see that the data mesh is driven by the technology change or the organizational change?
Well, that's an interesting question. I think the technology change is the one that enables this. A few years ago, there was no data mesh. There was no concept of a connect paradigm over a collect paradigm. It just didn't work. Now the technology is getting there. I'm seeing a few implementations of a data lake of a data mesh that truly work. The interesting part is that organizationally, we are also seeing some changes that actually push to the same concept. Many countries are now putting data in, and they're saying, hey, listen, I don't want to share all my data. I really want to keep my data local where possible and only share when needed. Well, guess what? I can do that now. And especially countries like Turkey, and we have a few other countries where there's a huge push for, hey, listen, this is my data. It can't just leave the boundaries of the country. But I still want to have the same implementation. I still want to have the same governance. I still want that data to be findable, but not per se consumable. It's a very different thing. So the two things go hand in hand.
We have another question here. What problem does Algoria address over some open source metadata products?
Well, the biggest thing is that it's not per se only an implementation of a metadata solution. It is really an exchange format that makes it possible to connect solutions of existing vendors and create that metadata highway. We started out as a very much an IBM shop. When we implemented our data lake many years ago, we did that with the IBM technology. But we have a lot of people that really want to do, a consumption of data to Power BI. We now have a solution of connecting the two together. And when we did our central governance in IBM Watson Knowledge Catalog, when we now see that data in Power BI that connects to Purview, the full set of metadata is available. We know where the data comes from. We know what the data means. So in that sense, it is much more of a metadata highway than purely a metadata product. It is, and it's an open source implementation, meaning that I don't have a discussion with different vendors that say, hey, listen, my product is the de facto standard that everybody can connect to me. That's great, but nobody wants to connect to you because you are a competitor product. Well, guess what? Algoria is an open source thing. It's not a competitor product. So I'm actually making a lot of headway with the different vendors saying, please connect, and you're connecting to everybody, right? So Microsoft is now doing work with us, and they've already committed to making this part of the product. IBM has done so, SAS has done so. We're making good progress with Apache Atlas. It is becoming an open standard, and the fact that it's open and that everybody can contribute and that's not a competitor, it really helps us.
That's awesome. The next question, I guess this should be a very collaborative project that involves the full company. So in an international context, especially, where do you start from and how do you bring everyone in?
Well, that's a big question. It is absolutely a very collaborative project. I mean, bringing this together, doing this across all the countries, definitely involves a lot of collaboration. So how do we involve everybody? Well, making sure that we actually sell the story to everybody. We do the presentations, we talk to them, but we're actually in the lucky circumstances in ING that we set up a strong central data governance organization that is in charge of the entire data lake technology stack as we have it. Our data lake in every country is identical. Even more so, we're actually bringing them, not physically together, but at least we're bringing the whole governance and the whole operationalization and the whole management of that stack for all data lakes together in a single team. Single team, actually the teams sit in multiple locations, but they have the same backlog, they have the same steering, they have the same governance. You know, it is in essence one international team. And by doing that, you actually bring people on board. It's not just kind of like a Dutch thingy that we bring to all the other countries of ING or a head office activity. It's much more of a thing we do together. And that is in essence the success of the data lake from day one, that we did it together and that we did involve all those different countries. And you know, we had these sessions which we call in the past the 5 minutes of fame. And we brought all the people from the different countries together and everybody had their like 5 minutes in the spotlight where they can share their ideas. And that's how you bring the different countries in. You know, everybody's involved. And if you involve somebody from, say, Turkey, they become an advocate. They don't say, this is head office thing, you know, I don't believe it. No, I was part of that journey. I contributed to that journey. And, you know, I'm a believer, so I'll also advocate this journey and this solution to the people in my country. And that has worked really, really well for us. So making it international, bringing the people together, I think that's been the key to success, and it still is. We still do this with people from different countries. Part of my team sits in Romania. They build a lot of the stuff. Another part of my team sits in the Netherlands. We involve people from all the different countries of ING. We're now doing an implementation with Australia. I mean, we're making this international from day one.
Building champions, it sounds like, which is a big deal.
Yep,
how can data mesh potentially manage the confidential data at scale?
Well, the data mesh needs to manage all the data of the bank, right? And marking data as confidential just means that we have to take different measures of access to data. So one of the things that we're doing is saying that, you know, really everybody who accesses data needs to go through a data mesh. That gives me a very strong enforcement policy set of engines that I can actually say, listen, you can't get to the data unless this is governed data. We know the confidentiality. We know all these things about the data. We know your role because you're an ING employee and you've gone through the AD and we know what you do, where you work, etc. If this data is confidential, you need to have a purpose, which you need to express to get to this data. There is no way around these policy enforcement points to get to the data. I mean, like literally none. And that way, whether this is public data, hey, everybody can see it, whether it's confidential data, we know how you get to the data. We have very, very strong policy enforcement. And that is, I think, the key to making sure that people can trust this, because if people see that the data can't leave the country, if there's a policy saying the data can't leave the country, you can't get to the data unless the data owner has given you access or people with your role access. If you can't get to the data, there is a workflow that, you know, lets you ask for permission. That permission can only be given by the data owner. There is no way to bypass the governance. There is no way to go to the data directly. Everything goes through this, you know, data virtualization layer, which is part of the data mesh. And I think that is how you do it.
When did you start this initiative, and what are some challenges of adopting in the early stage of the data mesh approach?
Well, we started to work on the data virtualization part as a first start of this a few years ago. And to be honest, data meshes, in my personal opinion, are not yet very mature. I mean, we are in the early days. It's great technology, but I think today, and I think some of you have seen other presentations as well, if you want to do a data mesh today, you have to assemble it yourself from different technologies, and well, it's a lot of work. And I think that is one of the things that we're all facing, where data meshes over time should kind of like automate, the hell out of everything. Today, we are actually building that automation, so we're just shifting the problem. So I think what we've done is, well, first of all, we've tried to work with a partner in this, a vendor, where we believe in. We've done it kind of like in proof of concept, in MVPs. We've built it out little bit by little bit. We've told the organization that this shift is coming, that this is an evolutionary move, rather than, hey, we have to start from scratch, everything we've done so far we have to throw away. No. Everything we've done has value. Nothing is going to break. All the data you've put in is still there. It's safe. We're not breaking anything. We're just making your life simpler. And we are introducing this slowly, small pieces by small pieces. First, data virtualization to have that, policy enforcement layer. Slowly, we are automating, the data ingestion part. Then we do the data movement part. We're doing demos. We're doing all these showcases. I think that's the way to do it. I think if you want to do this big bang today, good luck. I wouldn't advocate it.
You have to eat the elephant one bite at a time, as they say.
Indeed, there's a lot of bites there.
Lots of bites, that's right. With data mesh and open metadata technologies, does it mean the future data management and governance will be decentralized as well?
I think there'll still be central governance, because if you're a big international organization, you need some central governance on data. I think what the good thing is that we will allow for countries to very clearly, on a decentral level, say what they allow other countries, even if it's head office, to do with data. And they'll do that by actually saying, listen, my data has these policies. At the moment, they have to do this actually by a technology implementation, right? I mean, they have to say, listen, I just will not build this job to move the data to head office. In the future, they say, I have my data mesh implemented. My policy says personal data can never leave my country. That implementation is done across the globe. We know that the data from Turkey is always my favorite example, cannot leave Turkey. And Turkey sets that policy. And I can't overrule that centrally, because that's a policy set by Turkish regulators, set up by our Turkish organization. And that policy enforcement point sits at the boundary of Turkey, and it executes in Turkey. There will be no Turkish data leaving Turkey. So in that sense, it becomes a bit more decentralized, but still central governance on, this is the ING Esperanto, this data is needed for regulatory purposes, this is the moment in time I need to have it, this is the data quality that I need to have. That has to be done centrally. You can't distribute that, because it's a central need that has to be translated to a decentral implementation. So it's going to be a mix of things.
That makes total sense. And I think the final question we actually have here, we have one more minute. If we also want to use open metadata Algoria, do we need to have a data catalog in place?
You don't. You can actually use Algoria as a data catalog. It has all those functionalities as a complete implementation of a data catalog. If you already have a data catalog, it will, of course, connect to it. Well, depending on the vendor, not every vendor connects to it yet. But if you actually start from zero and you have a lot of open source technologies, it would actually be a really nice starting point to start with Algoria as your central data catalog. I give you, the UIs are not the most beautiful in the world. But if you have some comments on the UIs, talk to us. I will make it better for you.
The feedback means a lot. That's right. We actually have an additional question here. The country-specific policies sound a bit like the attribute-based access control introduced by Netflix from last week's talk.
I didn't see that talk, so let me have a look at it. And if you reach out to me directly, Stefan, then let's have a conversation on that.
Very good. I think that that concludes all the questions that we have. Thank you so much, Ferd. As you can see, for those that are attending, feel free to navigate down this page. You'll find other resources from ING, other examples of the things that they're doing, and certainly you'll be able to go a little bit deeper. Again, thank you for your presentation and for your time, and we look forward to doing it again at our next event.
Perfect. Thank you very much, all. I appreciate all the questions.